Right, when we are finding increasing, decreasing, max, min, concavity, etc. of functions, the first thing we need to do is find the critical numbers. So these are where f prime of x equals 0 or where f prime of x is undefined. Either one works. When we're finding the absolute max or min value, that's different than finding where the relative max and mins are. Where is like, oh, at x equals 2. But I could have lots of relative max and mins in an interval, whereas the absolute value, there should just be one absolute value. And I want the actual value of the function, not where it is, so the actual f of blank x. Here we actually have to plug into the equation, and we need to check not just the critical numbers, but also the endpoints. If you want to find just where it's increasing and decreasing or where the relative max mins are, then you don't need to plug into the function, you just need to plug in like the signs of f prime. F increasing, your justification is because f prime is positive, decreasing f prime is negative. Relative maximum is f prime changes from positive to negative, and then relative minimum is f prime changes from negative to positive. Concavity, we need to find possible points of inflection, that is where f double prime equals 0. Concave up is f double prime is positive, concave down is f double prime is negative. But sometimes we don't have f double prime, we just have f prime. For concave up, f prime is increasing, and concave down, f prime is decreasing. For a point of inflection, you need, first of all, f double prime has to be 0/undefined, and f double prime has to actually change signs. Or f prime can change from increasing to decreasing or vice versa. Right, so our actual maximum and minimum value of a function on a given interval, first we need to find our critical number. So f prime is 6x minus 24. Set that equal to 0. That's going to be x minus 4. So x equals 4 is my critical number. So I need to test the endpoints and my critical number. This is where, so this is where you can go to your y equals function. You can type in, we're plugging into the f, not the f prime, 3x squared minus 24x minus 1. And then now I can do the f4, the green f4, y1 of, what am I checking, negative 1, y1 of positive 5, and y1 of 4. So this one is 26, this guy is 46, and this guy is negative 49. So I want to know the maximum. So the absolute max is, what was my maximum? 26 at x equals negative 1. And then my absolute minimum on the interval is negative 49 at x equals 4. Do the same thing here, 6x squared minus 6x minus 12, x squared minus x minus 2, x minus 2, x plus 1 equals 0. So then you have a critical number of 2, negative 1, and then you also have to check our endpoints. So then you plug these into your function and you get, should grab my key. Alright, f of 2 we have negative 21, f of negative 1 we've got 6, then this one's negative 5, negative 10. So then the max is 21 at x equals 2, and your absolute minimum is negative 10 at x equals 3. Oh, that's not right, that's a negative. That's my absolute minimum. And then my maximum is the positive 6, yeah, max of 6 at x equals negative 1. Okay, C, this is quotient rule, so low d high minus high d low, low d high minus high d low, underneath the low squared goes. So I'm going to clean that up, that's x squared plus 2 minus 2x squared, which is minus x squared plus 2. Nothing is going to make the bottom 0 because nothing squared plus 2 is going to give 0 because nothing can be negative here. So I set the top equal to 0, you get x is plus or minus root 2. So I'm going to find f of root 2. I actually don't need to check f of negative root 2 because that's not in my interval. So f of 0, f of 2. And you get, this one is 0, this one is like 0.353, this one is 0.333. So then this is my max value here, and this is my minimum value here. Here we are finding where f is increasing or decreasing. So first find f prime. That's going to be x squared plus 3x minus 10. Set equal to 0. That's x plus 5, x minus 2. So x equals negative 5 and 2. Now I just want to know increasing or decreasing. So here I could just make my number line of f prime. I plugged in 0. That would give me a negative. And then these are powers of 1, so it'll flip on either side. So then f is increasing for x less than negative 5 and x greater than 2 because f prime is positive, and f is decreasing between negative 5 and 2 because f prime is negative. Where we have a relative, so you've got a relative max when f prime, so I'm going to say because f prime changes from positive to negative, and that is changing from positive to negative at x equals negative 5. And then you have a relative minimum at x equals 2 because f prime changes from negative to positive. Concavity, we need to find f double prime. So f double prime, take derivative of this, that's 2x plus 3. So then set that equal to 0. You get x is negative 3 halves. Make our number line for f double prime. If you plug in 0, this is positive, so this one is going to be negative. So this is saying that f is concave up for x greater than negative 3 halves because f double prime is positive, and then concave down x less than negative 3 halves because f double prime is negative. Points of inflection is where f double prime changes signs. Well, it's changing at x. So point of inflection at x equals negative 3 halves because f double prime changes sign. Here I have f prime. I want to know where I have a relative max and min. So first I set f prime equal to 0. So that's going to give me x equals 0, 2, and 3. And now I make my number line of f prime. 0, 2, 3. Here, any value of either of these is going to be positive because no matter what I get inside, it's getting like squared and to the fourth. So actually don't look at these. I'm really just looking at the x cubed. So it's negative here for negative numbers, and then anytime a positive number, these are all going to be positive. And it makes sense that it's not changing signs over the 2 and the 3 because these factors actually have an even power. So where I have a relative max is none. So there is no relative max because it never goes from positive to negative. And I have a relative minimum at x equals 0 because f prime changes from negative to positive. Here I have the graph of f double prime. I want to know where g is g double prime. G is concave up. That means g double prime is positive. This is a graph of g double prime. So where it's positive is negative 3 to negative 1. And 2 greater than 2 because you literally have a graph of g double prime and it's positive there. F double prime is given, and I want to find points of inflection and intervals of concavity. So first I would set this equal to 0. That gives me x equals 0, 1 half, and 3. I'm going to make my number line for f double prime. If I plug in a negative number, that's going to be negative, that's going to be negative. Doesn't matter what this is because it'll be positive no matter what. Negative times negative is positive. If I plug in less than 1 half, then that will be negative, that would be positive, so negative. More than 1 half, this is positive, and then this is still positive because this won't change signs over the 3. So then concave up, so concave up, f is concave up for x less than 0 and x greater than 1 half because f double prime is positive. F is concave down, 0 to 1 half because f double prime is negative. And we have a point of inflection at x equals 0 and 1/2, but not at 3, because you need f double prime to change signs. And it does not change signs at 3. It's 0, but it doesn't actually change signs. So 0 and 1/2 are my only points of inflection. Decreasing, so first I need to find the derivative. So this would be 2e to the negative x plus 2x e to the negative x times negative 1, because chain rule. So I'm going to pull out the e to the x. That leaves me with 2 minus 2x. Set that equal to 0, because we want to set f prime equal to 0. Nothing makes this 0, but 1 would make this 0, so x equals 1. F prime, just testing 1, so let's plug in 0 here. That would be 1 times 2, so if I plugged in 0, this is positive. And if I plugged in 2, that would be negative, because it would be 2 minus 4. So then decreasing for x greater than 1, because f prime is negative. Next we have to do, well, actually you don't have to use quotient rule. What am I saying? You can just rewrite this as negative 3 times x plus 2 to the negative 1. Now I need to find g double prime, because we're talking about concavity. So first g prime, that would become positive 3x plus 2 to the negative 2. Take the derivative again. This is negative 6x plus 2 to the negative cube. So this is lactase. Okay. Now, to test concavity, first I need to find my possible points of inflection, so set this equal to 0. That means I need to test around either side of negative 2, which is g double prime. If I plugged in 0, that would be 2, which is going to be, oh, this isn't a negative anymore. 2, 8, that would be negative over a positive, so that's going to be negative when x is 0, and positive over here. So it is concave up for x less than negative 2, because g double prime would be positive. 8, we are looking at the graph of the derivative of f, so this is f prime, and I want to know how many relative maximums. That's when f prime changes from positive to negative. So here, doesn't actually change, so the only one was 5, so I have 1. Points of inflection is when it changes from increasing to decreasing or vice versa, so here, here, and here. I have 3 points of inflection. And where do I have inflection? X equals negative 3, x equals 2, and x equals 5, but for 2 different reasons, right? Negative 3 and 5, because f prime changes from decreasing to increasing to increasing. And at x equals 2, because f prime changes from increasing to decreasing. Both are points of inflection, right, because f double prime is changing signs. But I can't say f double prime is changing signs because I was given f. So f is changing from increasing to decreasing or vice versa. Relative minimum, when f prime changes from negative to positive, so that is at x equals negative 1 because of this reason. Concave up is where f double prime is positive. I don't have f double prime, so that's the same as f prime increasing. And where f is decreasing is where f prime is negative. So I want to look where it's negative and also where it's increasing. So here I have literally negative values, but the values are increasing. So that is between negative 3 and 1, negative 1, because f prime is increasing, that means concave up, and negative, that means decreasing f. Where is it concave up and increasing? So concave up, I need f prime increasing. And then for f to be increasing, that means f prime must be positive. So positive and increasing is here and here. So negative 1 to 2 and 5 to 7 because f prime is increasing and positive. G of x is sine. Where do we change from concave down to concave up? So g prime is cosine. G double prime is negative sine of x, because I want to find g double prime number line. So I need to set this equal to 0, where sine is equal to 0 is 0, pi, and 2 pi. So x equals 0, pi, and 2 pi. And I actually am only on the 0 and 2 pi interval, so I need to check at pi. Careful, because if you're thinking just the sine of sine, from 0 to pi, I do have a positive sign, but my g double prime is negative sign. So if this is positive, it's a negative positive, which means this is negative. And then here, where I actually have negative sign values, I'm multiplying by a negative, so I'm going to get a positive g double prime. So it's changing from concave down to concave up right here at x equals pi, because g double prime changes from negative to positive. G double prime negative is concave down to concave up. Woo, going fast. Okay, positive f prime means increasing. Positive f double prime means concave up. Positive f prime means increasing. Negative f double prime means concave down. Negative prime f prime means decreasing, and positive f double prime concave up. Negative decreasing. Negative f double prime is concave down. So I just look at the concavity, and then the part that's increasing is this one, so it looks like this. Here, concave down but increasing, so that's this part, looks like this. Concave up but decreasing, that's the decreasing part, looks like this. And concave down and decreasing, the decreasing part looks like this. Here, this is f prime, and I'm looking for f, so I know that I'm increasing, then I'm decreasing, then I'm increasing again, decreasing again, and lastly increasing. So I need to start increasing, yep, they all start increasing. I need to end increasing, yep, so not this one. And I need to go increasing, decreasing, increasing, decreasing, increasing. This goes increasing, decreasing, still decreasing, increasing, not increasing, decreasing, increasing, nope, increasing, decreasing, increasing, decreasing, increasing. Wow, how many times can I say creasing? So this is the one that goes with it because it's the only one that matches. You can also check that concavity matches. Here, this is concave down, so I would have a decreasing f prime. This is concave up for a little bit, which is why I have an increasing f prime. Concave down a little bit, and then lastly concave up, which is why I'm increasing f prime again. Here, this is f, and I'm trying to find f prime. So here I have positive f prime, negative f prime, and then positive f prime. So I want to start positive, middle negative, end positive. Positive, negative, positive. Positive never goes negative. Negative, positive, negative, that's flipped. Positive, negative, positive. So now I'm between these two. It's not enough to just check positive sign, or the signs of f prime. I also need to know is f prime increasing or decreasing. That has to do with concavity. So I start concave down. Concave down is negative f double prime, which means f prime is decreasing. And then here, this is concave up, that's positive f double prime, which means f prime is increasing. So I need f prime to start decreasing and then end increasing. Start decreasing and increasing.